kind of getting our ducks in a row here. And our topic today is we're going to do a little bit of very short number of two dev news items, and then we're going to jump into the AWS Post-Mortem from the outage. Was it last week?
Last Wednesday.
Last Wednesday. So just putting all the links in here for our producer, Becker, and we'll get started. One more second here. And thank you for joining if you've joined. Fantastic. We appreciate you watching the show. All right, welcome everybody to another edition of TechChat Tuesday for Tuesday, December 1st, 2020. I'm Ken Rimple, and with me today I have, trying to find a way to sit in that little quadrant or that little triptych. My name is Ken Rimple. I'm a Director of Training and Mentoring Services at Cherry Solutions. And I'm joined today by two of our frequent guests. We have Sujan Kapadia on the right of me, all the way on the right. And Sujan's our Director of Development. Is that the right term? I always get this wrong.
I think we use a different title every week. It's all good.
Yeah. Developer power person. I don't know. But our guest today for the topic at hand is Keith Gregory, AWS Practice Lead.
Hey.
Welcome, Keith.
Thank you.
All right. So we're going to talk in a few minutes about the recent AWS outage that took down a lot of services in the US East 1 region. They had a really good summary, and we'll get into that in a little bit. And we'll talk about some of the ramifications and some of the things that it could be prevented in the future, may not be, who knows, but we'll get into a whole discussion around processes and how to architect your applications and some of the concerns and how you weigh them. So that's kind of the main goal of this particular thing. Before we get started with that, though, let me just jump on and tell you that you can certainly find a lot of other material from Chariot, including videos and blog posts and things like that. Our upcoming event that I'm running is called Build a Cloud Native Web App in 8 weeks. We've done a number of applications now using containers and running containers in the cloud on AWS and also other platforms. So in this webinar, I'm going to go through how to take an application from concept to production based on 4 specific use cases. If you pick a couple of reasonable use cases, what do you need to do to stand up the project? What kind of team do you want to assemble? What kind of tools and techniques might you use? And what are some of the things you'll run into? And so that's what we're going to talk about. And so that is going to be on December 9th, noon to 1 p.m. It's completely free, so please register. We'd love to see you there. We already had a number of people sign up for that. And hopefully, impart some useful tips and quote-unquote wisdom to you as you approach the next project that you need to roll out in the cloud. If you head over to our blog page, which is Resources Blogs, there's a whole bunch of stuff out there. You can find things like, 15 minutes with sessions, which are sessions about, challenges in tech that interface with business. Our Java 25 event, and blog posts if I go further down. Also, you can reach out and go to our YouTube page at youtube.com/Chariot Solutions and see a ton of our content. Videos from all of our TechChat Tuesdays, all the 15 minutes with videos themselves. If we look at our playlist, we also have emerging technologies for the enterprise conference talks. So, for example, we've got Philly ETE 2020, all the talks from that, and also prior years as well. So that's all available to you. All right. So first things first, though, let's take a look at some quick developer news items. As soon as I can find there it is in here, my links. All right. So first thing is, I thought this would be interesting. Is the 12 days command challenge, 12 days of the shell. So I thought this would be fun for you, Keith, because you're a shell person and do a lot of shell scripting. You're
a shell of a person, Keith.
You're a shell of a man. But on the first day of shell, my true love gave to me a list of files in the directory tree. S1 all of us can do. And so the idea is, can you pass all 12 days of shell challenge? And that's at 12days.cmdchallenge.com. I thought that was a fun little thing for people to play with. It's kind of holiday festive. And then you have challenges for each of the quote unquote days of shell. That was kind of humorous. But if you're a person stabbing out and starting in shell scripting and dealing with shell commands, it's a different world, but it's really useful to be a shell person, I think, especially because most systems are, these days either Windows, but mostly Linux or Unix, and always have been. So not bad to see what you know.
Yeah, and I'll add to that, it's great to have little helper utilities that you write once you learn shell scripting.
Yep, make your own bin directory, put them in there, write stuff.
And putting them into version control somewhere, so when you want to use them again, you don't lose them.
Mm-hmm.
I've made that mistake too many times.
Hey, what's your favorite shell? I like Z shell. I like my ZSH is my favorite environment.
I switched from C shell, which nobody uses anymore, to Bash maybe 10 years ago, and I'm not ready to switch to anything else. Call me a
I've
Luddite.
been using my ZSH for a number of years. I can't say it's my favorite or not. I haven't used enough of them to make a educated opinion on that.
Mm-hmm. Mm-hmm.
One thing that I will say is a lot of scripting, I've moved more and more to Python. And it's nice.
Yeah.
I'm using that professionally quite a bit. So it's nice to have one language that you work in.
Yeah,
one
absolutely.
set of libraries. Yeah. Not looking for 30 different command tools like, cut and send, awk and grep and stuff. You just go in there and use Python for it. Yeah.
If you start getting really crazy with Netcat at a previous client a number of years ago, I started doing that, and I'm like, screw this, and I just rewrote the whole thing in Python, and got it done faster, and it was a lot easier to maintain and change in the future.
Good points. Definitely good points. Has anyone here seen The Queen's Gambit yet, or started watching it on Netflix?
Haven't.
So, it's this story of a female chess master who, against all odds, becomes really, really good at chess by learning it in her, their orphanage that she was living in, and moves on to great success, but struggles with addiction and all sorts of stuff. It's a really interesting story. I'm only in the beginning of it, but it seems like chess is bubbling up again. I am awful at chess. I'll just say that now. I can sometimes beat my brother, but both of us could not beat a flea. But I thought that it was fun. This came across Hacker News. Chess Tactics Explained is like a basic introduction, a warm introduction to, chess. So you see that, you've got a number of puzzles and solutions. I don't know if either of you, brother, I don't know if you hear that, but there's a weed eater outside. So I'll just quickly get through this. Different openings, different gambits, different attacks, different ways of handling things, how to pin different pieces down. Are either of you chess players at all?
I'm not.
Hard pass. Got it. All right. Well, while the leaf blower is freaking out in my neighborhood, I'm going to throw it over. I don't mean to do this to you, Keith, but I'm going to throw it over to Keith to talk a little bit about the failure in AWS that happened last week. So I know a lot of services went down. Can we kind of just at a higher level just discuss it? I know that there was a wrong one. There we go. So there was a summary of the event that showed up on AWS. They do a really good job of documenting all the things that happened in Post-Mortem. So let me throw it to you to just have a quick kind of high-level summary of what happened.
Sure. So to give a little bit of background, I've been working with Kinesis, which was the root cause, pretty much since it came out, and also Kafka, which is Apache's open source player in the same space. So have a little bit of familiarity with how these things work. And one of the things that I maintain on my spare time is a logging framework that writes logs directly to both Kinesis and CloudWatch logs. And the way I learned about this outage was I tend to do major changes starting Thanksgiving week. And I had started off with a new edition and made some changes that was just refactoring, shouldn't have changed anything. And then I ran my integration tests and everything failed. And so it was a quick scramble on my part to figure out what was going on. But yeah, I don't want to dive into the technical details. Basically, what happened is the way that they deploy it. And if you think of Amazon Web Services, a really good way to think of it is that you have a giant load balancer, just like a Elastic load balancer, that you make a request, such as putting a message on a Kinesis queue or publishing a CloudWatch event, and that load balancer goes to some service that handles the event. And they have it split up so that you have front-end services that accept these web requests and then pass them on to back-end services. And internally, the way that it kept track of which back-end service had a bug that was dependent on the number of front-end servers. And they added more capacity to the front-end servers, and it started taking down the entire system. And you can get a lot of retrospective, well, they should have known this. I'm not going to go down that path because this is what I think of what Nassim Taleb calls a black swan event. And he used 3 categories. And a black swan event comes from nobody in Europe had ever seen a black swan. All swans are white. So as far as they were concerned, up until 1697, there was no such thing as a black swan. Then they went to Australia and discovered that, oh yes, there is. So Taleb uses these 3 characteristics of what he describes as black swan events, and he develops an entire system of socioeconomics about understanding them and preparing for them. But the first is that it's something that no one sees coming. Until you went to Australia, you'd never see a black swan. And a lot of AWS outages are like that. Kinesis, as I said, I've worked with it for 5 years. It's very bedrock technology. I would never expect it to go down, but it did. Same thing with S3 in 2017, is you just don't expect that to happen. The second feature of a black swan event is it has just major consequences. And in the case of this recent outage, CloudWatch was built on top of Kinesis, so that when Kinesis started failing, now you couldn't publish CloudWatch metrics, you couldn't publish CloudWatch log messages, and autoscaling is built on top of CloudWatch metrics. So as a result, autoscaling was unavailable. You couldn't automatically respond to load to add or reduce the number of instances you had. And some people apparently had auto-scaling rules that if they got no information on which to make a decision, made exactly the wrong decision. So huge impact from something that you could not foresee. And then the third is that Taleb says that black swan events are very easy to explain after the fact. So it's very clear what happened with this outage and how it manifested itself after the fact. So this isn't a mystery. This is something that's fully explainable. But still, understanding what happened in this outage is not going to prepare you for what happens in Amazon's next major outage. So the practical effect is that you have to start thinking, if you're going to deploy on Amazon, or really on any cloud provider, because every cloud provider has outages and limitations, you need to think about how you're going to deal in case something happens that basically takes you down. And I'm going to kind of jump a little bit. Before this, I was watching Andy Jassy's keynote for reInvent, which is virtual this year. And early on, he put up a statistic that said that right now, only 4% of enterprise workloads are running in the cloud. So this is going to be something that people have to think about. For him, it's great. It means that Amazon Web Services has a lot of room to grow, but it's something that the people who are moving those workloads to the cloud really have to think about. And I can go on and talk about some of the ways that I've been thinking about this, but I think I'll stop, and if the two of you want to jump in.
So I did have a question. How quickly did Amazon figure out the root cause? Did they share how they did that? It was part of that logging or not?
So I don't have my glasses on and I don't have the post-mortem up in front of me. My recollection was that the outage started early morning Pacific Standard Time, and they had a lot of logging, but the logging was giving them kind of inconsistent or incompatible information. So it took them a while to actually figure out, and there we go. Ken just magnified 9:39 a.m., identified the root cause, and then trying to figure out.
Like, it's what I can do with all the leaf blowers out here.
And then try to figure out the best way to compensate for that root cause.
Right. Yeah. The reason I asked about logging was I was curious whether, like, observability or how they had that set up for their own stuff helped determine the root cause fast or rapidly.
Well, certainly they have some level of logging because I think it was about 3 hours from the time they realized the problem to the time they actually figured out the root cause.
So here we go. At 5:15 a.m. Pacific, the first alarms began firing on errors for putting and getting Kinesis records. Right. Teams engaged and began reviewing logs. So yeah, so it was about 5 a.m. Was it 3 a.m. that the outage started or something like that?
Yeah, it's pretty amazing. I mean, like to your point about the black swan events, right? It's like you may not be logging the thing that needs to be logged because you never foresaw it being a problem.
Right. Right. But, one of the big things, and as both of you know, logging and observability is kind of near and dear to me, is to be able to log enough information and have access to enough information to be able to infer what's going on behind the scenes.
There was a real struggle there. Like they were getting a lot of novel errors that they weren't, they were wading through to try to find things. As their diagnosis work was slowed by the variety of errors observed, seeing errors in all aspects of the various calls being made by existing and new members of the front end fleet, exacerbating their ability to separate side effects from the root cause. So this was a complex problem to troubleshoot for them.
Right.
The next question I had, which you may be covering later, so you don't answer now, is did this affect companies that are deploying their services dependent on Amazon in a multi-region way?
Yeah, I want to talk about that a little bit later.
Okay.
But yeah, I think, and we can move on to that if you'd like.
Whatever you have, whatever you guys want to do, it's fine.
I mean, the ultimate thing was, if we got to the root the root cause, was something that was a configuration issue that wasn't, it wasn't something that they expected. Like they ran out of basically operating system threads on the Kinesis machines.
Right.
When they added additional capacity that exceeded those threads. So they ultimately got to that was the root cause in the
right. And diagnosing a problem like that can be incredibly challenging. It's like out of memory errors in Java, where my joke with an out of memory error is that when you have one, you might not have enough memory to create the exception to report the error.
Very true.
I can ask a stupid question. I know you didn't want to dive into technical details, so you can say, we can talk about that offline, but the stupid question is, why does every member of the front-end fleet need to be represented as a thread on each of the front-end servers for membership?
So I, of course, don't know anything about Kinesis. What I do know is Kafka, and Kafka does, or at least when I was using it heavily, did exactly the same thing. Because with Kafka, at least, any given message can go to any of your brokers. So if you're writing, you make a connection to your broker and you send messages to that broker, and then that broker decides what actually should process the message. So both Kafka and Kinesis have this idea that you have a topic or a stream in Kinesis language, and inside of that you have multiple independent shards, and based on some characteristic of the message that you send in Kinesis, you give it a partition key. The message has to go to a specific shard based on hashing of the partition key. Yep. So when you're using Kinesis, you have two different calls. One is put record, one is put records. And they probably get handled the same way on the back end. I wouldn't see a reason for them to be different. But in put records, you're going to have some number of records that have different partition keys and have to go to different places. Now, again, this is a lot of assumption about how AWS works, but if we assume that you're connecting, when you make an API call, you connect to something that's equivalent to an Amazon load balancer,
Sure.
probably a network load balancer. It's simply going to pick out a front-end server to handle your request. That front-end server talks to some number of back-end servers directly, but then has to know what back-end server to talk to hand off messages where the partition keys aren't what it expects, aren't things that it already knows how to handle. Now, we could dive into, should every front-end server have a connection to every other front-end server?
That was really
not
the hard
going to go there.
All the other stuff you said made sense, but yeah, that was the heart of it. It was like a lurking ON problem. An ON threading model seems scary.
Yeah, and it could, I suspect that it's a performance situation where, again, you get a request coming in, you want to turn around that request very quickly. And in my experience, 50 milliseconds is the time it takes Kinesis to turn around a request. So the front-end server has to send those different messages in the request out to potentially different back-end servers. It may not know where the back-end server is, so it has a cache of what back-end servers should handle which shards, which partition keys. If it had to go out and just send out like a broadcast request to the network, which you wouldn't want to do, saying, hey, who can handle this? That's going to be a performance issue. And they said that they have DynamoDB having the authoritative reference of what goes where. But even so, if you're making a connection to DynamoDB as part of processing, say, up to 500 records in one request, that can just tremendously slow down your performance. So I can understand why they would have a system where when a new shard comes into existence, the front-end server that's directly connected to that then sends out information to all the others. So it's a design choice. As I said, it's a design choice that Kafka, at least when I was using it, made. It's a design choice that really can, with an appropriate level of processing capability, it can scan quite a ways. But when you're dealing with the size of Amazon, the scale of Amazon, apparently not.
Thank you for going through that in detail.
Yeah, and if you look at the post-mortem, they have a lot of information that they're sharing about what they're going to do to improve the service. So, for example, it looks like the less computers they have doing, less nodes they have doing the processing with larger, beefier CPUs and memory, because the scaling of the problem goes up as you have more and more nodes that have to communicate. That's one of the things they're doing right away. They're also, this is good to see, they're fine-grained alarming for thread consumption in the service, and will finish testing an increase in the thread count limits in the operating system config, which will give you significantly more threads per server and additional safety margin there as well. I mean, part of the challenge is with all these managed services is they are managing them. You're not managing these services, so you're using Kinesis as an end user of the service. So they're communicating exactly what they're doing. It looks like to do things in the short term as well as the medium term, which I won't go into all these things. So if you're curious about what they're doing to make Kinesis even more robust when it has issues, like where they're configuring it to handle larger amounts of traffic, they're certainly right on it and putting their strong focus on it. So that's good to see.
Right. And they may take a completely different approach where they, for example, there are tremendous number of architectural approaches. You could do things as figuring out a hashing that directs you directly to an IP address, so that you have a table of where things should go based on a hash of some value. I'm sure they're going to solve that.
They're also going to work to more safely decouple the other services from the reporting into Kinesis, I think, or at least make it more fault tolerant to that, which is what made things like Cognito go down.
That's that's kind of the big and scary thing to me is I can understand them wanting to use their services. And again, something like Kinesis is up until last Wednesday a rock solid service. Uh, but yeah, it's the far-ranging effects. So
Yeah.
Cognito would apparently have an in-memory cache of, or an in-memory list of notifications it had to send out, but then they didn't bound that list, and that can happen. You know, I think most engineers will say that they always check bounds on the values they deal with, but until you've been burned, no. And how you handle this. So I'm going to talk about my logging library for a little while here. It's designed to write to backend services. It has an internal message queue. And fairly early on, I put bounds on that message queue, which you can configure if you're configuring the library. But which sort of discard? So I give you three options for configuring to discard. By default, it discards the oldest messages you're sending out. So it's basically like a ring buffer. But that may or may not be how you want to deal with things. If you want to have in the approach I've taken assumes that you want to have the messages about what's happening as recently to diagnose problems. You may actually find it more important to hold older messages, or you may, with my library, make the decision, and it's your decision of saying, I'm going to let it hold as many messages as I have memory for and never discard anything, because getting every log message out is critical to me. So those sorts of decisions are best put in the hands of the people who are using it, but they have to be made. And you have to, I think, be burned by not having back pressure before you're ready to make those decisions.
So
That was a
let's
little bit of
talk
a
about.
ramble.
Sure, no, that's okay. Let's talk about like so the impact was a lot. Anyone who architected, and let's just talk about this like rationally, right? So anyone who architected their systems and then deployed them in US East 1, if they used any of these services, they were down.
Pretty
Um,
much.
so, but then putting it in context, unplanned downtime. Every organization has that serves services like that has a particular service level agreement, and they have a certain amount of outage that ends up being either planned or unplanned. This was a black swan event. It wasn't expected before. Um, so, I guess the question is, could you have, as a person architecting a solution, AWS, could you have planned a solution that would have prevented you from going down if this went down? And what's the practicality of that level of planning?
Yeah, and that is the quite literally million or multi-million dollar question.
I'll take a check.
So I had experience with this company I was working for in 2017. We ran entirely out of US East 1, and with the S3 failure, and I'll talk a little bit about the S3 failure. It was a situation where you were not able to read or write from S3. And again, lots of things depend on S3. For example, if you use CloudFront, chances are you serve your static assets from an S3 bucket, and that's for a web app, things like your style sheets, your JavaScript. You're just pulling that straight out of S3. In our case, we had a web application, a consumer-facing web application. CloudFront will cache things locally, so people on the East Coast, when the outage happened, already had things in a CloudFront cache. But then this was a business that worked, this was an application targeted at a business that works normal hours. On the West Coast, those caches hadn't been filled yet. So they couldn't even see our site because it was going out to CloudFront. CloudFront went out to S3 and couldn't retrieve the static assets. So East Coast, and it took us a while to understand things were going wrong because the S3 outage did not affect our running fleet of servers. We saw our servers running, traffic would drop a little bit, but really, if you had everything from a CloudFront cache, you were able to use our application. Where things went really haywire is we had scaling. So we would scale up I can't remember the number of instances. Let's call it 4 instances at 8 a.m. Eastern time up to 12 instances at noontime Eastern time as the people in the West Coast came online. But S3 is also how Amazon stores Amazon machine images. So when S3 was out, now all of our auto scaling failed. We would try to scale up and couldn't start the instance because it couldn't read the instance image from S3. So it hurt us. It basically took us offline, and we had to scramble to, I think we brought up, I'm not sure if it was GoDaddy or Google App Server or whatever, but we basically brought up an entirely new website saying, sorry, we're down right now, because we couldn't even change to our normal outage page because that was a static asset served through CloudFront from S3. So it took us down for a day. And afterwards, we talked about what would be necessary to fail over to a different region. And all the capabilities are there. Okay, we were a company that did, I think, $7 million, $8 million a year in business. And we were paying a significant chunk of money for our AWS services in US East 1. And we went through to be able to do a regional failover, say from US East 1 to US West 2. Replicating all the buckets, pretty straightforward, relatively inexpensive. Having realistically the auto scaling groups all configured and ready to go, so there would be time to scale to start those up, to start up the actual instances. Our big issue is our database. We had a database server, an RDS database server that had about 1 terabyte of live data. We had the primary and then 4 read-only replicas to serve traffic. So replicating that database cross-region and preparing for that, and more importantly, being able to actually flip it live, because you could do a semi-warm backup where you just had one server running, and it would be a replica of the primary server, and you could switch over, and we were able to do that. We had been ready to promote replicas all along, but it takes time to start bringing up more servers. So either we pay for a complete fleet of RDS instances on the in the other region, which would have run, I think, $4,000 a month to do that, or we suffer startup delays as we have this one replica. Now we have to replicate it out to the multiple other servers. And if you do that, one of the things with switching over with disaster recovery is that once you do that failover to the West Coast, now you have to plan and pay for your failover back to the East Coast, right? You don't have master databases. They exist, but you would shift all of your traffic, lose some amount of data because of shifting the traffic, and then you'd have to go through and plan to go back. And I've only known one company that actually did this successfully, a company that I worked at 12 years ago, fairly large e-commerce company, and they did a failover every single night. They had 2 data centers. This was pre-cloud. And they had an Oracle, their main database was an Oracle database with, I think it was called Golden Gate, so that it would replicate everything. And they flipped a switch every single night to switch all of their app servers from one data center to another one across the country. And I really think that they're doing that every single night was the only thing that made them able to smoothly recover when things actually went wrong. Because if you have a disaster recovery and you never switch over, how do you know it's going to work? So you have to plan if you're going to be setting up cross-region disaster recovery. You have to plan how you're going to do it, and you have to exercise that often. Now, for the company I was working with at the time, we looked at it. We looked at the extra costs. We looked at the operational costs, and we said, you know something? We can call up our customers and beg forgiveness rather than spending, I think, the costs are somewhere in the $10,000 a month range, which is a significant charge for a company that's doing $8 million in business. And then, sorry, I'm going to do one final point on this. So let's say you implement your cross-region replication, and you can do it. Aurora, for example, which it has a great story for high availability within a region, also has the ability to fail over between regions, although it's a fairly manual process. But again, Black Swan event. What happens if the next Black Swan event for Amazon takes out IAM or takes out, basically, there are very few services that are not confined to a region, but there are some, or it takes out Route 53 DNS.
Mm-hmm.
It's very much a cost-benefit analysis, and you have to figure out what you could do. And some people go down the idea of multi-cloud. So they're running in Amazon and running in Google or running in Azure. And that brings its own set of, sorry?
But then you could fail in those as well, right? Yeah, you can have
Well,
you can have failures in Google or Amazon or Azure
yeah,
as well.
it's
You're adding to
basically,
the footprint, I guess.
you're hoping that they don't all fail at once. But again, to make that work, you have to exercise that failover. You have to do it constantly.
We need a multi-planet solution.
Yeah.
Oh, we're going to Mars. We're going to Mars.
I love that
Mars
latency.
East region.
15
Yeah, it'd be
minutes, I
great.
think.
But it's like 2 hours or
One
whatever.
way.
So yeah, so and just to point out that these Black Swan events that happen, it's not like these happen every day. They happen pretty infrequently, and they are not. You can't plan for everything. If you were building your own data center and doing your own thing the old-fashioned way, your own hard drives are going to fail. Your own systems are going to fail. So even doing it internally in your own company, you're going to run into things, and you're the one managing all of that. So
Right.
it's not like you can plan for every eventuality, but I guess it's the question of how rational is it for you to spend the money to architect something that is so bulletproof that sure it can fail over for you automatically or manually, provide you the global failover possibilities. If your company needs that level of failover, then you're going to pay for it.
Right. And for Netflix, it's a necessity. But Netflix, I hate using Netflix as an example because they're also in a situation where simple latency and storage drives them down to a multi-region solution. Looks like we lost
We
Sujan.
lost Sujan. Wait, he's back. Well,
So
hello.
Netflix is probably a bad example of why you would go multi-region, because I think their drivers are not failover. Their drivers are normal operation. There are, I'm sure, companies that it's worth it.
Yeah.
Pick a large consumer products company, for example. If you go down, you might suffer significant damage to your reputation. Think of, for example, well, a recent example, Garmin was down for a week earlier this year as a result of ransomware. And I don't know, I certainly didn't switch off use my Garmin watch for an Apple iWatch, but it's a risk for them. Is okay, people who are fanatical runners or cyclists, they lose that access. They might choose to go with a competitor.
If a home security system and its ability to notify authorities, et cetera, things like that require going through some cloud servers that happen to be down, and the incident occurs during the time that's fatal, or you never know.
Well, and not to bring up because it's in the summaries and in the blog posts, but like there was a really good BBC article on this, and it was like I can't vacuum my house because my Roomba won't work, or the Ring video doorbell. The IoT devices get baked in with their firmware to talk somewhere, right? So this is going to hopefully make people think about that as well. Like, what can we do to make it so that we have an alternative path for things that need to be that available?
Right. But people have to do it intelligently.
Would you say if you're going to architect and deploy, what are the hazards of going to US East 1 first, if there are any?
Yeah, and you're I think referring to a quote from our friend Eric, who said you should never develop and deploy in US East 1. I think you have a link to that with several reasons why. US East 1 is where Amazon tries out everything new. So I've been thinking about that a lot, and most of the outages do happen in US East 1. It's the S3 outage was US East 1. You get the newest services, the newest updates, but you also run, I think, a slightly higher risk of having problems there.
You had a great lunch and learn on June 21st, 2020, that you got together with two other AWS architects, Eric Schmidt from Moven and Bill Thompson from Lafayette. And you had a really good story from one of them about how they deployed Lambda for the first time, and then they had to deploy to Australia. And this was just when Lambda had just launched in US East and a few other regions, and it didn't exist there yet.
Right. Yeah, that was Eric's comment.
Yeah. So like knowing what services exist in the different regions is important. Like, we were architecting a solution this year, and we had to use SES, right? Simple email service. And, my offhanded comment was like, well, put it in US East 2. And you're like, you can't do that because it's not in US East 2. So knowing what services are available for the regions you're targeting is really important as well.
Right. Yeah,
That's a great video, by the way. I love that talk. There's some great war stories in there that if you're curious about the kinds of things people face dealing with cloud solutions, specifically around AWS, things to do and not do. I love that. That's a great session.
Keith, AWS GOV government stuff, does that run on a completely separate, dedicated everything?
I don't know, but I would have to assume yes.
Different data centers, basically.
Yeah. Yeah, Amazon, like most large computer services providers, is very secretive. There was an article in Wired or Fast Company a few years ago, a person who, using public property records and driving around, basically found the Amazon data centers in US East 1. But Amazon doesn't really talk about that.
A whole bunch of guys got into a van. Just kept moving hard drives. Move, quick, run.
Heavily guarded, I assume.
Yeah, I would not offer, or I would not ask to go and take a tour of the data center.
Yeah. Something in your past, Keith? No.
No. Although a company I worked with a few years ago actually had written into some of their contracts with their clients where the data was saved, and some of the clients demanded to do an on-site audit, and this company would actually take clients to the data centers, and then part of the issue with migrating to AWS for them was that no, that's no longer going to be possible.
Yeah.
We worked with a pharmaceutical client a number of years ago that came to Chariot to audit the stuff we were using and the office.
Yep. It's in legal contracts, and that will change based on that. That's true. All right, great. Well, I think this has been a really good conversation. This will be online, obviously, for people to look at, and we'd love to hear your comments. If you have anything to say about your experiences in architecting cloud solutions and things you've faced or ideas you've had, please tweet them to @TechCast. We'd love to hear from you. You can also send us feedback on this podcast at techcastfeedback@chariotsolutions.com. And our show notes will be up on the YouTube post for this as well. So, Keith Gregory and Sujan Kapadia, thank you so much for joining me today for this. This has been very informative.
Thank you.
Yeah,
if I don't eat lunch soon, I'm going to have my own outage. So
go avoid outages, folks. Talk to you later.